Alright, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So one sample for proportion MGT 555. So we continue under statistical inference, chapter number 5. So in this video we are looking into one sample for proportion. So many key business measures are expressed in terms of proportion, such as sales growth, market share, product return rate, customer acquisition rate, employee turnover rate, and etc. Thus, it often to conduct a test of hypothesis about a proportion of the population. So the hypothesis testing for population proportion is similar to hypothesis testing for population mean. So we are using the Z test for one sample test for sample proportion. The formula for sample proportion is Z equal to P hat minus P, means the population of estimated population, which is a calculated population, minus estimated population proportion, divided by square root of PQ divided by N. So this is the Z value or test statistic that we're going to use for one sample test for sample proportion, where P is the hypothesized, means that P is the estimated proportion and P hat is the calculated proportion. So to understand further about the calculated proportion and estimated proportion, let's look at example number 3. So this example is about Express Computer Company. It's an online-based company that sells tablet, personal computers, and laptop. So the company claims that at least 80% of all orders reach the customer within 3 days. Means that this is the expected proportion. So it claims that at least 80%, means that more than 80% of all order reach the customer within 3 days. Means that our hypothesis statement, so our null hypothesis will be P is more than or equal to 0.80, means that more than or equal to 80%. So the alternative hypothesis, if we are claiming that the order will be fulfilled more than 80% in 3 days, the alternate will be P is less than 0.80. So within 3 days means that the order would be reached to the customer less than or equal to 3 days. Means that less than 3 days lah. The quality control manager wished to check the validity of the claim made by the company. So he took 120 orders. So this is going to be our N, right? And delivery time as stated in Excel Express computer delivery time. So we need to open the Excel file, Express computer delivery time. So you can get this file from UFuture. I already put it into discussion, so you can download the file. So using 5% significant level, so our alpha here will be 0.05. So we want to test, is the claim made by the computer true, by the computer company is true. So we want to know whether the claim made by the computer company that the computer will reach the customer within 3 days more than 80%. So first step, to conduct the hypothesis, we need to state the hypothesis statement, which is we already did this one. So the null hypothesis will be P is more than or equal to 0.80. the alternative hypothesis P is less than 0.80. So we know that this is going to be a one-tail test because the alternate hypothesis is less than. So our alpha is 0.05, right? So next step is we need to state our test statistics, right? So test statistic that we're going to use is Z test, where equal to P hat minus P divided by a square root of PQ over N. Right. So now we are looking into our Excel file. So in our Excel file, we need to put some value lah. So first step, we're going to type statistic, and this is going to be our value. Right. Let me. Right. Okay. So now we need to state our alpha. Our alpha is 0.05 and our P is 0.8%, 0.8 proportion, which is 80%. And then we need to calculate our P hat. P hat means that the number of mailing times, the proportion of mailing times less than 3 days. So if you look at the mailing time, that we have 1 until 5 days. Let's say we highlight all the column here for mailing time, and if you look at the bottom side, we have minimum value is equal to 1 and the maximum value is equal to 5. So now we want to select only we want to calculate the proportion of mailing time less than or equal to 3 days. So we want to calculate P hat. So in order to calculate P hat, we need to count how many mailing time less than or equal to 3 days. Mailing time. So okay, count mailing time less than or equal to 3 days. Right. So to count this mailing time, so we are using count if function. So we're going to select from B4 until B100, B123, right? So then we want to select let's say 3 first, 3, and we're going to plus count if B4 until B123, we select 2, right? So means in this process is we want to count how many mailing time for 3 days plus mailing time for 2 days, mailing time for 1 day. So count if B4 until B123, and then we select 1, right? So now we are counting for how many 1 day, how many mailing time for 1, how many mailing time for 2 days, and how many mailing time for 3 days. So we got 102. So next we need to calculate our total data set, our total observation in mailing time. So we use count A, right? So from B4 until B123. So we got 120. So to get P hat, we just need to divide for 102 divided by 120. So we will get 0.85, right? So now in our formula, we already obtained this value, which is P hat, and we also know P value, which is proportion value. And for denominator, we already know the PQ value, and we also know n value. So next we need to calculate the z statistics. Right, so z statistic will be our p hat minus p divided by the square root of, if you look at the formula, square root of pq divided by n. So square root sqrt p multiply with p hat divided by our n here, right? So since n is also included into a p square root, so we need to put extra bracket here, and this one going to be 0.66. Oops, sorry, actually this one is wrong, because p multiply with q. P means that our p is 0.8 multiply with q is the complement of p, so we need to 1 minus 0.8, right? So then we will get 1.36931. so this is the correct answer, right? So we already know the value of z statistic is 1.369. So we put here 1.369, right? Okay, next step is what we need to do is we need to calculate the critical value. So critical region lah, critical region. So since this is a skewed one tail test to the right, this is a one tail test to the left, right? Because it's a less than to the left, so we are trying to draw a normal distribution curve and put on the left. So this is going to be our mean, right, to the left. So this is going to be our rejection region. So let me put here, this is a rejection region, and this is going to be acceptance region, right? So we want to know what is this value, what is the value of the critical value. So the critical value, right, let me calculate here, critical value. So for the critical value, what we need to do is we're going to use normal distribution sample, inverted, right? So 1 minus alpha is 0.05. So this is going to be 1.644. So since the value is on the left value, so this is going to be negative 1.6445 lah, right? 45. So we run out to 3 decimal points, so 1.645. so the formula you can get it from the book, where if you want to find the critical value for one tail test, right, for this is for t test, right? Let's say for critical value for z, critical z value, so normal as inverted 1 minus alpha. So this is the formula that I used previously just now. So next step is we need to set our decision rule. So what is our decision rule? So decision rule, if this is what we call as Z Z statistic, Z 0.05. If the critical value Z 0.05, let me clear this one. If Z calculated, so this is a Z calculated. If Z calculated is less than Z 0.05, which is 1.6 negative 1.645, so null hypothesis is rejected. Means that if the value of Z statistic here is less than this one, means that it's fall inside the rejection region, so we will reject null hypothesis, right? So our decision here is, since the Z calculated is more than, which is 369 is more than Z 0.05, which is negative 1.645, so it falls under acceptance region, which is on the right hand side. Null hypothesis is accepted. So we can make a conclusion that our conclusion is the claim made by computer store is supported by our statistical hypothesis. Or we can say is in other word is we have a 95%, since our critical alpha is 0.05. We have 95% confidence that the customer, more than 80% of the customer items are delivered to the within 3 days, right? I think that's all for one sample proportion. Okay, Assalamualaikum.